Hi everyone, welcome to today's lecture. So this is lecture 2 under vectors. So my name is Hampton, and today we're going to look at the dot and cross products of vectors, and then apart from that we'll also look at the cosine, direction cosines or direction cosine angles. Okay, so let's quickly begin. So here, first, before we even start solving this question here, the first thing that you need to understand is what is a direction cosine, or what is a direction cosine angle. Yeah, so to explain that, I want you to look at this diagram here. So this diagram, when you look at it, it has the z-axis. It's showing the x or y or z plane. It is in 3 dimensions. So it has the x-axis here, it has the z-axis, it has the y-axis. So when you talk about the direction cosines, we're simply talking about the cosine of these angles that we've been given here. The cosine of alpha, the cosine of gamma, the cosine of beta, those are direction cosines. And these direction cosines are given by cos alpha, which is this alpha here, which is the angle between the given vector and the x-axis. So cos alpha is just given by this will be a, we all know to say, so this will be a over the magnitude of the given vector v or u. It can be vector v, vector u, vector m, depending with the vector that you've been given. So if this vector v is just, for instance, v is equal to this vector that we've been given, this one in blue, v is equal to a I plus b j then plus c. Okay, so if this is your vector that you've been given, you just get your a there and then divide by the magnitude of this vector. And of course, I know we've all up to now we know how to find the magnitude of a vector. So you find the magnitude of this vector and then you divide a by that vector, then that's the cosine, that's the direction cosine of this vector, yeah, in the x-axis. So the first direction cosine that we have is cos alpha is equal to a over the magnitude of v. The second one will be cos beta is equal to b over the magnitude of v. And then the last one that we have is cos, okay, not the last one, but there might be others, but the other one that we have in 3D is cos gamma being equal to c over the magnitude of v. So these are the direction cosines that we have. And if you've been told to find the direction cosines, this is what you do. And then if you've been told to find the direction cosine angles, so when they add angles at the end, when they say find the direction cosine angles of direction cosine angles of any given vector, you simply just make alpha here the subject, meaning alpha will just be equal to the cos inverse of a over the magnitude of v. Same applies here. You also find beta, where I say beta is just equal to the cos inverse of b over the magnitude of v. So even this one, the last one, you do the same. Gamma is just the cos inverse of c over the magnitude of v. So this is basically what you do. Yeah, so and then apart from that, these, I think, apart from that, the other thing that we can talk about the cosine direction, or rather the cosine angles, yes, the direction cosine angles. The other thing that we can talk about is simply just the square of cosine alpha. So cos squared alpha plus cos squared beta and then plus cos squared gamma. This is always supposed to give you 1. Yeah, so this is always supposed to give you 1. When you try to prove this and then it doesn't give you 1, note to say you have made a mistake somewhere. Okay, so let's now quickly move on to solving this question. So I'll solve either 1 or 2 questions from here. So in other words, we have solved this question. So already we have solved this question, because this one is just, we are just going to change where there is v here, we'll put u, that's all, because the vector that we've been given is u. So you just put u there, and then we've been given a, b, and c. So this is what you just have to do. And then here on the magnitude of v, you just have to put the magnitude of u, the magnitude of u, the magnitude of u. So I've solved question 4, and then this is just the first step of solving this question. And then the second step should consist of, for instance, when you write a on top, the denominator there, instead of being the magnitude of u, you put the actual magnitude of u now. So the actual magnitude of u is simply just the square root of a squared plus b squared plus c squared. So you put this as your denominator on all these 3 cosine directions, direction cosines. Yeah. So in this case, we've just been told to find the direction cosines, meaning we don't need to reach this far. We don't need to write this part. So just directly from writing the direction cosines which are here, you just go on and prove that when you add the squares of these direction cosines, you get the answer 1. This is what the question is asking us to do. So let's quickly solve one question from there, and then we'll count it that we've solved 2 questions together with this one. So I'll solve the first question there. Okay, so the first question says u is equal to that. So the first thing that we can do is to find the magnitude of u. So the magnitude of u is simply just the square root of 1 squared and then plus 2 squared plus 2 squared. So all these are supposed to be in brackets in case there is one which is negative there. Okay, so the magnitude of this will simply just give us, so this will be 4 plus 4, it will give us 8 plus 1, that's 9. So the square root of 9, which is just 3. So we found that the magnitude of u, so the magnitude of u is simply just equal to 3. So from there now we can write our direction cosines. So our direction cosines will now be cos alpha will just be equal to, so cos alpha will just be equal to a. My a here is simply just 1. The coefficient of I there is 1, which is, so the direction cosine, the first direction cosine will be 1 over 3. Then the other one that we're going to have, you get your b there, which is 2. So we're going to say cos beta is just equal to 2 over the magnitude of u, which is 3. Then we also write the last one, which is cos gamma. So cos gamma will just also be equal to you get that c of yours there, which is 2, and then you divide it by the magnitude of u, which is 3. So now the question goes on to say, demonstrate that the sum of the squares of these direction cosines is 1. So the sum of the squares, meaning, remember what I wrote at some point, I said cos squared alpha plus I said cos squared alpha plus cos squared beta plus cos squared gamma is always supposed to give us 1. So let us prove and see if this is going to give us 1. So here we're going to say the first one, we have cos alpha that we have is 1 over 3. So we're going to say 1 over 3 squared plus, let's also take this one, which is 2 over 3 squared, and then plus the last one, which is 2 over 3 again, 2 over 3 squared. Let's see if this is going to give us 1. So we've been told to demonstrate that this is going to give us 1. So this one will give us 1 over 9. The other one, this one will give us 4 over 9. And then the last one, which is this part, will also give us 4 over 9. So when you add this, since we have the same denominators there, so meaning we just add the numerators. So 1 plus 4 plus 4 will get 9. And then 9 divided by 9, the answer will give us 1. So we have demonstrated that this is going to give us 1. So this is how you solve even the other two questions that have remained. Yeah. So let's quickly move on to the next question. So here we've been told to find the direction angles. So in the same way that I solved the previous question, that's the way you solve this one, except that when you reach this part, you now begin to just say, anyway, let me just solve one. Okay, I'll get, which one should I get? I'll get the first one here. So the way you solve this question, you first find the magnitude of that u. So the magnitude of u will give us just the square root of 3 squared, which is 9, plus 2 squared will give us 4. Negative 2 squared will also give us 4. So this is 8 plus 9, that is 17. So this will give us the square root of 17. So the square root of 17 is the magnitude of u. So apart from that, let us now find the cosines. So first, before you find the direction cosine angles, you first have to find their cosine. You first have to find the direction cosines. So the first direction cosine that we're going to have is cos alpha. Okay, cos alpha is just equal to the first a that we have there, the coefficient of I is just 3 over the root of 17, and then the other one is 2 over the root of 17. So we say cos beta is equal to 2 over the root of 17, and then cos gamma is just equal to negative 2 over the square root of 17. So having found this, we are now supposed to find the angles, the direction cosine angles. So how do you find that now? You just say, you just make the angles the subject. So here we'll first make alpha the subject. So alpha is just equal to cos inverse of 3 over the root of 17. So if this is not a special angle, you can just leave it like that. But if they are special angles, you simply go further to solve and find the actual angle. So same applies to the second part here. You have beta is equal to cos inverse of 2 over the root of 17. Same applies to this. If this was a if this was what's this okay, if this was something that is that for instance is what's this a special angle, we would have gone further to find the final answer. Same applies to gamma. Just do the same. So this is cos inverse of negative 2 over the root of 17. So sometimes it's important for you to rationalize this, because sometimes if you rationalize them, you discover to say they give special angles. Yeah. Okay, so but I'm pretty sure when you do that to these, you still remain with the same answer. So when you rationalize, for instance, the first question here, cos alpha should remain as, instead of 3 over root 17, you can write this as 3 over 17 and then root 17, like that. Yeah, so this is basically what you can do if you want to rationalize that. How did I do that? In case there is someone who's lost, you multiply this denominator with that. So when you multiply 3 times root 17, you get 3 root 17. Then when you multiply root 17 times root 17, you just get 17. And then this is a well rationalized what's this, cosine alpha term. Alright, so let's quickly move on to the next question. This was just straightforward. So now the question 14 says determine whether u and v are orthogonal, parallel, or neither. So on this question I will only solve one, because the questions are straightforward. You just need to understand what they mean when they say orthogonal, what they mean when they say parallel, and what they mean when they say they are neither parallel nor orthogonal. So let's quickly check this one here. So if you want to check whether these two vectors u and v are parallel, so if you want to check whether u and v are parallel, anyway, we'll also solve the last one, because I know everyone thinks when you see sine cos, you think maybe you've seen here. Anyway, let's quickly do this one. U, this one, and then v is that. And then if you want to know whether these two angles are orthogonal or not, you use the dot product. So we know to say for orthogonal angles, or let me first start by defining what are orthogonal vectors, not angles, sorry. For what orthogonal vectors are. So orthogonal vectors are vectors that are at 90 degrees to each other, such that when you find if this is vector A, then and this is vector B, so A dot B, so A dot B is equal to 0 for orthogonal vectors. Why are we saying A dot B is equal to 0? Remember what we said in the previous lesson. We said A dot B can also be written as the magnitude of A times the magnitude of B, and then we say cos, let me just write this properly, then we say cos, I don't know why my PC has started performing, okay, we say cos theta. So now imagine that the angle is theta. When we say, sorry, imagine that the angle here is 90. When you put 90 here, we all know to say cos 90. We all know to say cos 90 is a special angle, and it always gives us what? 0. So this 0 times everything here, you discover that all this part will go, just remain as 0. So A dot B is equal to 0 for orthogonal vectors. And then parallel vectors, remember what we said. For parallel vectors, if A is parallel to B, it means that A is a scalar multiple of B. Meaning, if for instance this is your A, if for instance this is your vector A, if for instance this is your vector A, vector B will just be some vector just parallel to A but shorter than A, because for you to find vector A, it means that you have to multiply vector B by a certain number which we call K. Then you find vector A, since vector A is longer than vector B. So when you say two vectors are parallel, it means that they are just scalar multiples of each other. So yeah, and then for neither, I can't explain this, means that it's neither parallel nor orthogonal. Yeah, so let's quickly start solving. I'll solve this one, I think even this one. Okay, let's quickly do this. So to determine whether this is orthogonal, U is orthogonal to V, what we can do is we find the dot product of these two vectors. So we have 4, 0. We find V dot, so we're finding V dot U, sorry, U dot V, which is just the same. U dot V is just the same as V dot U. So U dot V, we find U dot V. So U dot V is just the same as this part dot the other part, which is 1, 1. So let's see if this is going to give us a 0. So 4 times 1 will get 4. Remember what we learned on finding the dot products in the previous lesson. So 4 times 1, 4 dot 1 is 4, and then 0 dot 1 is 0. So we say 4 plus 0. So this is giving us 4, meaning these two vectors are not orthogonal. So they are not, these two vectors are not orthogonal. Let's try to check if they are parallel. So to check whether these two vectors are parallel, you try to find what's this? Okay, let's try to check if these are parallel. So for instance, that U can be written as 4i plus 0j. Then V V can be written as I plus j. So is there a number that we can multiply to V to get U, or is there a number that we can multiply to U to get V? If the number does not exist, or if that is not possible, then we just conclude by saying U is not equal to K V, hence not parallel. They are not parallel. Same applies to the previous to the first part I was answering to prove whether they are orthogonal or not. So in conclusion, you just say U dot V is equal to 4. It was equal to 4, so meaning U dot V is not equal to 0. Hence they are not orthogonal. Anyway, let's quickly move on to the last one here. So I'm pretty sure on these other questions that you have here, there might be 1 or 2 questions which are orthogonal and parallel. You can test them. So let's try to prove the last one here. So we find U dot V. So to find U dot V, we multiply the first term here with the first term there, the first term there with the second term there with the second term, the last term there with the last term. So we quickly do that. So we say cos theta times sin theta, we have cos theta sin theta. Okay, then we multiply sin theta times negative cos theta. So we're going to have negative cos theta. So we have, this is C, so negative cos theta sine theta. And then negative 1 times 0 there, you just get 0. So when you add cos theta sine theta minus cos theta sine theta plus 0, the answer that you get is 0. So your u dot v is equal to 0. So this implies that these two vectors are parallel. So they are orthogonal. So u is orthogonal. So you can conclude by saying, since u dot v is equal to 0, then u is orthogonal to v. Now, how do we show now if they are parallel to each other or not? Normally, when two vectors are orthogonal, it means that they are not parallel. Because when you have a vector facing that direction, then there's also a vector facing that direction. If this is your u, this is your v. This is your u and this is your v. You can agree with me that these two vectors can never be parallel. No matter how much they move going forward, they will never be parallel. So when vectors are orthogonal, it means that they can never be parallel. So since we've discovered that these two vectors are orthogonal, meaning they're not parallel, yeah, you can also try if you want, you can also try by just doing the method that I recently just showed you, where you find a scalar quantity or a constant that when multiplied to u, it will give you a function, or a constant that when you multiply it to u, it will give you v, or when you multiply it with v, it will give you u, which I'm pretty sure will not exist. So those two vectors are not parallel, they are orthogonal. But the first two vectors that we had were neither orthogonal nor parallel. Let's quickly move on to the next question. Alright, so we move on to the cross product. So when you talk about the cross product, the cross product of two vectors, here you'll be taken back to you'll be taken back to matrices. So when, for instance, you have maybe as I'm doing this, as I'm giving an example, let me be solving one question so that at least we move forward. So if you are finding u cross v, if you're finding u cross v, I'll just solve one question here. The first part, just so when I solve this, it means that you can solve this, you can solve that, you can solve that. Okay, so u cross v is just equal to, so u cross v will just be equal to, you write your I, you write your j, you write your k, and then from there you first start with u. You first start with your first letter here, your first vector. So if v is the one that was here, meaning I'll follow down here by writing v. Now since there is u here, meaning I'll first write my u there. So I'll write my 7, I'll write my 2, I'll write my 3 there, and then I'll write my v. So my v is 1, negative 1, then you have 5. Then when you find the magnitude of this cross product, so the magnitude will simply give you the cross product of u and v. The determinant, sorry, not the magnitude. The determinant of this will give you the cross product of u and v. So how do you find the determinant? According to matrices, so you say I times the minor times its minor. So I times its minor is just this part here, which is just 2, 3, negative 1, 5. Then we say minus j times its minor. So the minor of j here is just when you close this part, you also close that part. Whatever you remain with is the minor for j. So you remain with 7, 1, 3, 5. Remain with 7, 1, 3, 5. And then we move on to k. So we say plus k. So k here, we find the minor for k. The minor for k is simply just this part. So we have 7, 1, 2, negative 1. So here, don't forget there's always a minus here. So if this I was negative, it would change to plus. So there's always a minus there when you take the cofactors of the first line there. Okay. So let's quickly now find the determinants. So the determinant here, the first determinant that we have, we cross this 2 times 5 there, will give you 10. So we're going to have 10 minus negative 1 times 3 will give you negative 3. So 10 minus negative 3. So 10 minus negative 3 there. 10 minus negative 3. So we put I outside. Then we say minus. See 7 times 5, that's 35 minus 3. So 35 minus 3. 35 minus 3. Then we say this is j. Then, sorry, this is supposed to be j. Okay. J. Okay. J. And then we write our k there. 7 times negative 1, this will give us negative 7. So you can either write this before or after. So this will be negative 7 minus 2. 1 times 2 is just 2. Then we put k there. So here it's just a matter of simplifying this. So 10 minus 3, this will give us 13. So this is 13i. 35 minus 3 will give us 32, negative 32 j. And then negative 7 minus 2, this will give us negative 9k. Yeah, so I think I've solved. This is the cross product of these two vectors here. So to find v cross u, you just switch this. You take this down, you take this up, and then you take this one down, and then you find the cross product. Yeah. So you should also know to say A cross B is not equal to B cross A. So expect to find different answers here on these two. But know also to say V dot U is equal to U dot V. These, they are just okay. You still find the same answer. But for cross product, it's not the case. I think for cross product, it should be V cross U. Sorry, U. Okay, let me start with U cross V is equal to negative V cross U. This is how it is with cross product. Okay, so I think this is just something that you need to know. Okay, so we quickly continue with the solution. Okay, the solution is done just here. The solution is done. We found we found U cross V. So let me also just introduce something to you to find the area and everything using the cross product. So if this is your U cross V, if you now find the magnitude of u cross v, so whenever you find u cross v, expect to get a vector. And then when you find the magnitude of your answer, meaning if in this case if you find the magnitude of this vector that we've just found here, if you find the magnitude of this vector, this is equal to the area. So this is just going to be equal to the area of the parallelogram. Parallelogram. I don't know how you spell this. Parallel. Okay, parallelogram. Okay. So area of a parallelogram is just found by u cross v. So u cross v gives you the area of a parallelogram. So this is the area of a parallelogram. So now, the way it is when you find this, a parallelogram is just a polygon with two parallel sides. So it can be like this. At least it has both sides parallel, like that. You have these two sides which are parallel, even these two sides are parallel. So this is a parallelogram. So now imagine that we divide this parallelogram into two equal parts, and then we've been told to find the area of this part. So just when you look at this part that I'm shading here, this forms a triangle. So in case they ask you to find the area of a triangle, you just divide the area of the parallelogram by 2, like what I've done here. So in other words, the area of a triangle, so the area of a triangle is just equal to half the cross product, half the magnitude of the cross product of two vectors. So this is the area of a triangle. So you find the cross product in this manner. Then apart from that, you now find the area. Whatever vector that you get, you find its magnitude, and then half the magnitude. This one gives you the area of the triangle. So area of a parallelogram is just the magnitude of u cross v, and then once you divide this by 2, you form the area of a triangle. Yeah, so this is what you just basically need to know. Let's quickly move on to the next question. Yeah, so again here we have something here. So they're saying find u cross v and show that it is orthogonal to both u and v. So here what you just need to do is to find u cross v in the same way I showed you. You write your I, you write your j, and then you write your k, and then you write 12 there, you put -3 there, then you put 0 there, then you put your -2 there, you put 5, you put 0. So once you do this, you find the determinant of this. So after finding the determinant of this, let me just write this properly. Yeah, after finding the cross product of this, they are saying show that it is orthogonal to both u and v. So the cross product of this will always give you a vector. So u cross v is always a vector, but u dot v always gives you a number which is just a constant. Okay. So u dot v sometimes is called the scalar product. Sometimes in some books you find it written as the dot product. Some books will say scalar product. Then this one is the cross product. So this one will give you a vector. So when you find the determinant of this, you get a vector in the form ai plus b j plus ck. So now they are saying show that it is orthogonal to both u and v. So I'm trying to do things like shortcuts because I know that I've explained in the previous question how to find the determinant of this, and then apart from that I don't want to make the video very long. So after finding your final answer of u cross b will be in this format. Then to prove that to prove or to show that it is orthogonal to both u and v, you just find the same answer that you've gotten. So the same answer that you've gotten here, your answer that is ai plus bj plus ck. So you are just going to dot this. So you are just going to dot this with u in the first case. Then in the second case you dot the same vector with v, and in both cases you are supposed to get your answer as 0, because here you have not been told to verify, or you've not been told that they are not asking you whether it's orthogonal or not. What they have told you to say, it's already orthogonal. They know to say it's orthogonal. They just want you to show that it is orthogonal. So meaning in both cases here, when you dot your answer that you are going to get, with either u or v, the answers that you're supposed to get are both supposed to be zeros. Because remember what I said, the dot product of two orthogonal vectors is always supposed to be 0. The dot product of two orthogonal vectors is always supposed to be 0, because we know to say the cos of 90 degrees gives us a 0. Hence the dot product of two orthogonal vectors is always supposed to be 0. Alright, so let's quickly move on to this. So to show that this is orthogonal to u and v, you just need to perform these calculations here and expect your answers to be 0. Okay, let's quickly move on to the next question. So this other question is asking us to say, find the area of a parallelogram that has the given vectors as adjacent sides. So remember what I told you. So in other words, here they've told us to say there's this vector. Yeah, there's this vector. Let's do this. Okay, there's this vector. So you've been told to say there's this vector. Let me just put the arrow in between there. There's this vector which is vector u. There's also this other vector which is vector v. And then you've been told to say find the area of a parallelogram. So when you move these vectors, you're going to have something like this. Yes, something like that. So this is a parallelogram, and then they want you to find the area of this. So remember what I told you. The area of a parallelogram is just found by finding the cross product of the given vectors. When you find the cross product is just found by finding the determinant. Remember what I told you. The determinant, when you find the determinant, so you put your values of u there, your values of v there. Then when you find your determinant of the given two vectors, the two given vectors, you come now and just find the magnitude of the determinants. So the magnitude of the determinant that you've been given or that you found, the magnitude of the vector that you found will simply give you the area of a parallelogram. And we know to say, so the area of a parallelogram, that's what you're going to get. So we know to say whenever you find the cross product of two vectors, your answer that you'll get will be in the format ai plus b j plus ck. when you find the cross product, yes, the cross product of u and v, you find your answer to be in that format. So when you find your answer to be in that format, you now just find, this is not the magnitude but just the cross product. Then you now have to find the magnitude of your u cross v. We all know how to find the magnitude. You just say the square root of the numbers that you are going to have there, a squared plus b squared plus c squared. So when you find the magnitude of that, that is the area of the parallelogram. So that is the area of all this part. So that is basically what you're supposed to do on this question. So let's quickly move on to the next question. Yeah, so if I'm going to have time, I'm going to solve all these questions on a paper and then send a PDF. But the best you can do is to just follow the steps that I'm showing you. It's important for you to know how to solve than to see the solutions without knowing how they solved them. Okay. So question 18 says find the area of a triangle with the given vertices. So in the previous question we were given vectors. In this one we've been given vertices. So be careful sometimes when you have such questions. So in this case, what we've been given are just points. These are not vectors. If these were vectors, the brackets would have been like that. For instance, the first part there would have been, the first part would have been 0, 0, 0 in these kinds of brackets. But since these are points, that's the reason why the question is saying vertices, meaning these are just points. We have one point there, we have another point there, we also have another point there. So now, if for instance this is your A, this is your B, and then this is your C. So if this is your A, for you to find the vector A, B, you need to connect these 2 points. And then you're going to find the vector AB, and then you also have to find the vector AC. And then having these 2 vectors, you can now construct something like a parallelogram, which will look like that. Okay. And remember what I told you, when you want to find the area of a triangle, you can now divide this into 2 parts, which is just the area which you're going to have as that part. So meaning half the area of the parallelogram gives you the area of a triangle. So in this case, what you're going to do is this. So remember what I said, when you have points, let me just draw a quick one. So you have this point A, you have point B, you have point C. So what you need to do here, before you start finding the cross products and everything, the first thing that you need to do is first to find your, just to identify, just to get one point as your origin. So in my case, I'll get A as my origin. So I'm going to be starting from A, going to B, starting from A, going to C. So I'll first have my first vector, which is AB, and I'll also have my other vector, which is AC. So this is a triangle I want to find. This is a triangle whose area I want to find. So firstly, I'm going to find the vector AB. So AB, the vector AB will just be point B, AB. Remember what we said? We said vectors are found by terminal minus initial. Terminal minus initial. So the terminal there will just be B, the initial will be A. So this is just going to be B minus A. So my AB will now just be found by, so my AB is just going to be, AB is going to be, we subtract, set 1 minus 0, we get, this now becomes a vector, so meaning the brackets will change. So 1 minus 0, we get 1, 0 minus 0, we get 0, 3 minus 0, we get 3. So we do the same, we find AC. So AC is now just going to be equal to AC is just going to be equal to, we subtract, the terminal is C, the initial is A, so we're going to say C minus A. Oh, sorry, these are points, they are not vectors, so I wasn't supposed to put this. Okay, so we say point C minus point A. So we're going to say AC, which is a vector, meaning it's supposed to have a direction arrow on top. So we say negative 3 minus 0, we still have negative 3, comma 2 minus 0, we have 2, 0 minus 0, we have 0. So I'm just saying this minus that. So now we have these two vectors. So for us now to find the cross product, we need to take these two vectors. We need to take the cross product of these two vectors, which is just going to be A, B, cross AC. So AB cross AC is just going to be I, J, K. Then you put in your values, you have 1, 0, you have 3, then you have negative 3 there, you have 2, and then you have 0. So you find the magnitude of that. Then since we've been told to say, you find the determinant of that. And then when you find the determinant of this, your answer will be in the format A, I, B, J, and then C, K. So this is just the format which your answer is going to be. Your A, B, and C are numbers after solving this, after finding the determinant of this. So it's a long process, that's why I'm just saying your answer is going to be in this format. So now when you find AB cross AC, you now have to just come and find the magnitude of that. So the magnitude of AB cross AC, so the magnitude of AB cross AC will give you the area of a parallelogram. This parallelogram, if you remember the one I drew here, I drew something like a parallelogram here. So it will give you the area of this parallelogram. And then if you now want to find the area of a triangle from the area of a parallelogram, this is, so if you find the area of a parallelogram, so this is just going to be the area of a parallelogram. And then to find the area of a triangle, we said you just divide this by 2, divide your answer by 2 that side. So the final answer, in short, the area of so this is a parallelogram. Okay, so now to find the area of a triangle, we said you just find the area of just find half of the area of a parallelogram. So we say half times the magnitude of AB cross AC. So this is the area of a triangle that you've been asked to find. So this is now be the area of a triangle. So this is the area of a triangle. Yes, so this is basically how simple these things are. And then what else? So here the most important thing you need to put in mind is that you don't just need to use these points directly. You first have to get one point as your initial. If you get B, then you should find BA and BC. If you get C, then you should find C, B, and C, A. So in this case, I got A. That's the reason I found A, B, and AC, and then I used A, B, and AC I crossed AC and AB to find the area of a parallelogram, and then after that I divided the area of a parallelogram by 2 in order to find the area of the area that has been asked in the question. So what I've explained on this first part is what basically you need to do on this other part. So you just hold one point. Maybe you say you have P and Q. P, you have Q, you have R. So you say you are going to find PQ, you also find PR. Alright, so this is basically what you do. Let's quickly move on to the last question. So the last question in your tutorial sheet says a triangle has vertices. So this question I've explained on the previous question, because these are also vertices, meaning you first have to find AB, you also find AC, and then from there you actually it's the same question. Yeah, it's the same question. So you find AB, you find AC, and then you cross them. Then after crossing them, you find the magnitude of your cross product, and then having found the magnitude of the cross product, you finally just divide the magnitude of the cross product that you are going to find by 2 in order to find the area of a triangle. So let's quickly look at this question, which is part B of question 19. So part B of question 19 says find the measures of the triangle of vertices, the triangle whose vertices are that. Find the measures of the angles of the triangle whose vertices are that. Okay, so this question is simple. You just have to be a little bit imaginative to answer it, because you have a triangle like that. So you have this triangle, and then it has vertices A, you have B, then you have C. Okay, so you have a triangle which has these vertices. So this is simple and straightforward. So first thing, you find AB, you also locate your origin. You say you allocate your origin. So in this case, I'll get my origin to be A. So I'll find my AB, I'll also find my AC. So once I find my AB and AC, I know to say AB is just going to be B minus A, and then AC is just going to be C minus A. And then, so once I find my AB and my AC, I know to say AB, I don't know if I explained this in the beginning, AB cross AC. So AB cross AC can also just be written as the magnitude of AB. The way we wrote the way we're writing this format in using dot products times the magnitude of AC, and then here for dot product we are saying cos theta. Here now it's sin theta. So the angle that we're finding is simply just this angle. So this is the theta that we're finding, and then we've been told to find all the measures of the angles, meaning we need to find theta 1, theta 2, and theta 3. So we need to find all these 3 angles. So the first thing that we're going to do is that we're going to say AB cross AC, because I know to say U times V, U cross V is just equal to the magnitude of U times the magnitude of V sin theta. Don't confuse this with the dot product. U dot V, you have to use cos. So U dot V is simply just the magnitude of U, the magnitude of V, and then you put cos this side. So for dot there is cos this side, for cross there is sin that side. So here what you just need to do is to make sine theta the subject of the formula, so that you find your theta there. So this one I'm going to call it my theta 1, theta 1. So this one is theta 2, this one is theta 3. Okay, so to find this angle, I'm just going to say sine theta 1 is just going to be equal to the cross product of AB and AC, then over the magnitude of AB times the magnitude of AC. So this is what you simply just do. The video has now even gone to 1 hour, but anyway, it's worth it. So now imagine that I was solving all those questions. It would have even gone to maybe 2 hours or 3 hours, but it's good that I was just explaining. So to find theta now, you can just say theta 1 is just equal to the sine inverse of this part here. You write this part here. Here you say A, B cross what? You write everything over the magnitude of AB and the magnitude of AC. Write that. Okay. So I'm saying you write this part here. This part, you write it in these brackets. Yeah. So when you find the cross product of these two vectors, divide by the magnitudes. I mean the what's this? The product of their magnitudes, and then you find the sine inverse of that, you get the answer, which is your theta 1 there. Same applies to theta 2. So when finding theta 2, you don't use AB and AC again, no. So in this case, if you are finding theta 2, let me just erase this. So if you're finding theta 2, you don't use AB and AC. Instead, you get C as your origin. So meaning you are going to use CA and CB. So if we are finding theta 2 here, which is this theta, so instead of using AB and AC, we're going to use CB and CA. We're going to use CB and CA. So here the arrow will change. It's going to be CA. So we're going to say CA cross CB. Oh, sorry, not magnitude. I don't know why I'm writing the magnitude. Okay, so you say CA cross CB is equal to the magnitude of CA times the magnitude of CB. And then you write sine theta this side. Yeah, same applies to theta 3 here. So theta 3, you also have to use not using what we have used here for theta 3. So this one is theta 2. Theta 3, you are going to use BA. You are going to take your B as your origin. So you are going to take B as your origin. So you have something like this. So you are going to have BA cross BC. We're going to have BA cross BC being equal to the magnitude of BA times the magnitude of BC. Then you have sine theta 3. sine theta 3. So in both cases you make theta the subject. First of all you make sine the subject, and then you come and say sine inverse of BA cross BC over the magnitude of BA times the magnitude of BC. Then you make theta the subject, and then you find your theta. So if the theta that we're going to find is going to be a special angle, you write it. You finalize it. You write that special angle. But if it's not going to be a special angle, don't force yourself to find what you can't find without a calculator. Just leave it there. Okay. So let's quickly move on to B2. B2 is saying find the measures of the angles between the diagonals of a rectangle. So in this case we have a rectangle whose vertices are that. So meaning we have something like this. We all know what a rectangle is. So we have this, and then the diagonals we have are that. And then they're saying the diagonals between the diagonals of the rectangle whose vertices are A, B, C, D. So you have all these 4 points there. Then you have these points, and then they are telling you to say find the angle, the angles between the diagonals. So the angles they are talking about are these angles here. These angles here. So here you just need to think a little bit. So you can find this point, I guess. This is not so you can find this point. This point is not difficult for you to find. You all know how to find the midpoint. So the midpoint is given by, so you can first find that midpoint. So I'll call my midpoint M is equal to, you just get these two vertices. So you can sketch this. You put your A, your B, your C on points where they are supposed to be. You sketch it on the XY plane so that at least you have the actual triangle. The actual rectangle they are talking about. And then you find your midpoint using 2 points. You can either use this point there and that point, or if you don't want to use those, you can use this point and that point to find the midpoint which is there. Then once you find the midpoint, to find this angle here, you can just come and say this vector, you take this point as your origin. So you now find this vector cross this vector. So you are going to find now this vector cross this vector, and then you use, let's say for instance, if this vector is u and then this vector is v. So you say this vector, you're going to have something like u cross v is equal to the magnitude of u times the magnitude of v, and then sine theta. And then you make your theta the subject. So the theta that you are going to find is just this angle there. And then apart from that, this angle is equal to that angle. So once you just find this angle, it means that you've also found this angle. Then to find the other 2 angles, you can subtract this from 3 squared, this angle from 3 squared, and then divide it by 2. Or if you don't understand what I'm talking about, you can just use this same vector here, you cross it with that vector there to find this angle, and you are going to find it. Or in other or for those that may be interested to using this other part, you can use this vector there, this vector, and then you also get that vector, this one, you cross them together, and then you find the angle there. You make sine theta the subject, you find this angle. Yeah, so the most important thing here is just to sketch the triangle so that you get the actual points where they are properly. You know where A is, you know where B is, you know where C is, you know where D is, and then once you do that, you are going to get something like this. Then you draw your diagonals now. So when you draw the diagonals, then you find the midpoint there. You find the midpoint. Then once you find the midpoint, you find that angle, you also come and find the other angle. Then you are done with this question. Yes, so let's quickly move on to the last part of the question, which is part C, question 19C. Yeah, so this one is just the same way I explained. I think that was question 12. This question is just asking you to derive the direction cosines and the direction cosine angles, and to prove that these direction cosines are just simply going to give you, when you find their squares, you are just going to get 1 as your answer. So you've been told to say alpha is the angle between V and the positive x-axis. So alpha is the angle between V and the positive x-axis. Okay. And then they're telling us to say, having been given this information there, we have to show that cos alpha is equal to that. So I explained this, but for the sake of revision, let me explain it again, and for the sake of you understanding better. I think there was something I wanted to talk about question 19a. I've just forgotten. But if I remember, I think I'll come back and talk about it. Yeah, there's something I really wanted to talk about these questions. Anyway, if I'm going to remember, I'll come back and talk about them. Let's just proceed with answering this one. Alright, so we're talking about question 19c. We know to say alpha is the angle between the positive x-axis and the vector v, and then beta is the angle between the positive y-axis and the vector v, and then gamma is the angle between the z-axis and the vector v. So we've been told to say show that cos alpha is equal to a over the magnitude of v. So cos alpha is equal to a over the magnitude of v. How do we do that? So I want you to take these the axes, these axes to be units. What do I mean by that? For instance, when I talk about the x-axis, we know to say all vectors are in this format: ai, bj, and ck. So when you talk about the x-axis, I want you to know to say, when I talk about the x-axis, so I will name my x-axis, my x vector to be u. So my u is going to be, so I'll say let this vector be equal to u. My u is going to be in the x-axis. It's going to be a unit vector, meaning it has magnitude 1. So a unit vector meaning I'm going to have I plus 0j plus 0k. So this will be u in the x, then this is going to be u in the y. So u in the y is just going to be 0i plus j plus 0k. And then we also find u in the z. This is just going to be 0i plus 0j plus k. So this is supposed to be 0. Okay, so this is what I meant by saying units. So when you find the magnitude of this, you find it to be 1, even this one will be 1, even that one to be 1. So we can now find this angle. Let us try to find this angle. We know to say when we have this vector here coming this side, we also have this other vector. So to find this angle, we're going to dot them. Yeah, we can either use the cross product or the dot product, but in this case let us dot them. So yeah, we know to say the dot product at least is easily found, but the cross product you need to start finding the determinants and everything. So let us dot them. So we're going to dot these two vectors. This is the vector in the x, this one is the vector that has been given. So we're going to say the vector that has been given is v dot our u in the x. So this is just going to be the magnitude of v times the magnitude of u cos theta. Normally when you're finding the cosine, the direction cosines, you just dot, don't use cross product. I made a mistake to mention cross product. Yeah, so cos theta. So here what we've been given as our u is ai plus bj plus ck. So we write our ai plus bj plus, okay, so there we have ck, let me write this, plus ck. Then apart from that, we dot this with our u. So our u is just this, which is I plus 0 j plus 0k. So when we dot these two, we know to say this is going to be equal to the magnitude of v. So I'll just write the magnitude of v like that, and then the magnitude of u, remember what I said, this is a unit vector, meaning it's just going to be 1. You can try to find the magnitude of this vector, you still have 1. So when you write 1 there, so v times 1, you still get 1. I can just leave it like that, and then I'll write my cos there, cos, and then of course the angle that I'm trying to find here is alpha, so this is going to be cos alpha. So let us try to dot this. So ai times I, this will just give us a according to the dot product formula. Then this is going to be bj times 0, this is going to be 0 plus ck times 0, this is also going to give us 0. So I'll just remain with a being equal to the magnitude of v and then cos alpha. Yeah, so now to make cos alpha the subject, we're going to have cos alpha, being equal to you have a over the magnitude of v. So we have managed to derive this part. Yeah, we've managed to derive this part. So the same way I've derived this is the same way you do with beta. So on beta, while there is this u here, you're going to, this was my ux, so you're going to just put your uy, and then for gamma as well, you do the same. While there's ux there, you just put uz, just put this. Yeah, so you still have, so here I think they even made a mistake. They were supposed to put b here, this was supposed to be b, and then this was supposed to be c according to this vector here. So now to prove that the squares of these vectors will give us the squares of these vectors will give us 1, what we can do is, we know to say there's I there, there's b, there's c there, so we can say a over the magnitude of v, and then plus, so we're saying this squared, and then plus b over the magnitude of v, squared, then you say plus c over the magnitude of v, and then you say squared. We're trying to show that this will give us a 1. So let us see if this is going to give us a 1. So on top there we're going to have a squared, plus b squared plus c squared, and then everything here will be over the magnitude of v squared. So I've just skipped one step there. I know to say you know, or you've understood what I've done. So here I just skipped the step where I should come and find the common denominator, which is just the magnitude of v squared. So this is the part. Now, so how do you find the magnitude of v squared? So when you look at the v that we've been given is that, so v squared, the magnitude of v squared, rather the magnitude of v, we start first by finding the magnitude of v. So the magnitude of v is just given this v there, is just given by the square root of a squared plus b squared plus c squared. So now if we square the magnitude of v, if we square this, we're trying to achieve this part. If we square this, it means that we're also going to square this other part. Then when you square this, so we're going to have something like this. We're going to have something like this. So when you square this part, you are just going to have, let me just divide this. Okay, so you're just going to remain with this, because this will cancel with that square. The square root will cancel with that square, meaning you're just going to remain with a squared plus b squared plus c squared. So you can agree with me to say, while there's this part here, in this equation, we can replace with that. So let us replace that. So we're going to have a squared on top plus b squared plus c squared, and then everything divided by this part here, which we have found to be this. So we divide everything by that. Plus c squared. And then when you divide this by that, you simply just get a 1. So you simply just get a 1. So you just get a 1. So we have shown. So thank you very much for watching this lesson. If you have not yet subscribed to the channel, don't forget to do so that you won't be missing out the ones, the videos that I'm going to be posting. Click on the button that says subscribe, and this is the end of the lesson, vectors. See you in the next lesson that we're going to have. Shalom.